Okay, let's start with properties of alkanes. You guys can see the application, one of the applications of alkanes. The solid alkanes makes up a waxy coatings on fruits and vegetables, help retain moisture, inhibit mold, and enhance appearance. Everyone see the one of the practical application of alkanes. So the waxes that you find on fruits is nothing but a alkane compound. It is an alkane compound. So today we are going to look at different properties of alkanes. So by looking at these structures, you guys can see alkanes are non-polar in nature because the bond between carbon and hydrogen is non-polar. And if you guys are looking at alkanes, they are made of carbons and hydrogen. So alkanes are considered as non-polar molecules. Alkanes are considered as non-polar molecules. And also, if you guys are looking at the structures, alkanes with 1 to 4 carbons. So which alkanes have 1 to 4 carbons? Like methane, ethane, propane, and yes. And if you look at these gases, because they have very less number of carbons, they are gases at room temperature, and they are widely used as heating fuels. So the physical state of these compounds is gases. As the number of carbons increases from carbon 5 to carbon 8, the physical state changes from gaseous state to what? A liquid state. So you guys can see as the number of carbons increases, the physical state of these compounds is changing from gaseous state to what? Liquid state. For example, pentane, hexane, heptane, octane are in liquid state at room temperature. Now what happens if I keep increasing the number of carbons like nonane, decane, or carbons with 11 to 20? All these compounds will be changing from liquid state to solid state, like a wax. The solid alkanes feels like a wax. So you guys can see how the physical state is changing from gaseous state to a liquid state and from liquid state to a solid state as we increase the number of carbons. As we increase number of carbons. So alkanes with 9 to 17 carbons are also liquids with higher boiling point. Because they have a higher boiling point, you guys can see because the number of carbons are increasing. So these compounds are used in motor oils, kerosene, diesel, petrol, and so on. So let me ask you guys, now, what is a natural gas? Have you guys heard about natural gas? How many of you have natural gas at home? You can respond through chat. How many of you have natural gas at home? Is there anyone who has natural gas at home? So what is natural gas? Let me give you guys what is natural gas. Natural gas is a mixture of methane, ethane, propane, and butane. So if you guys can see, natural gas is not one compound, it's a mixture of compounds. It's a mixture of compounds with 60% of the composition being methane. 60% of the composition, 60 to 70 actually, 60 to 70% of the composition being methane. So especially if you live in states like Michigan and Wisconsin, they use a lot of natural gas. They use natural gas for heating, and they use natural gas for heating not only the house, but water and everything. So natural gas is widely used here. I think some places even in Texas has access to natural gas, and it's very cheap right now. So why it's cheap? Because it's not one compound, it's a mixture of compounds. It's a mixture of methane, ethane, propane, and butane, where 60 to 70% of the composition being methane. Now, what happens if the number of carbons are more than 18? So you guys can see as the number of carbons increases, the physical state is slowly changing from liquid state to what? Solid state. So alkanes with 18 or more carbons, known as paraffins, are known as paraffins or waxy solids. They are waxy solids at room temperature, like Vaseline. Petroleum jelly is a semi-solid, and it's a mixture of hydrocarbons with more than 25 carbon atoms. So the basic idea here is as the number of carbons increases, the solid state, the physical state of these compounds is increasing from a gaseous state to a liquid state, and from liquid state to a solid state. Now, as the number of carbons increases, I want you guys to think about it. What happens to their boiling point and melting point? So now let's look at here. Let me show you guys. Look at some examples. If you guys are looking at these examples, you guys can see methane has only one carbon. The boiling point is negative 164 degrees Celsius. Ethane has two carbons. The boiling point is minus 89 degrees Celsius. Propane has three carbons, and the boiling point is negative 42 degrees Celsius. Now let's look at pentane. The pentane has five carbons. It has a boiling point of 36 degrees Celsius. So can I make a statement here? What is happening to a boiling point and melting point as the number of carbons increases? As the number of carbons increases, the melting point and boiling point increases. Can I say that? As the number of carbons increases, the melting point and boiling point increases. Now, why the melting point and boiling point is increasing? Well, because of dispersion forces. Dispersion forces are also called London forces or van der Waals forces. So let me write down on the whiteboard exactly what is happening. Let's go to whiteboard. So the whole idea here is, let me draw you guys methane molecules. Let's say this is one methane molecule. This is other methane molecule. Methane, methane, methane. So carbon 1, carbon 1, carbon 1, carbon 1. So if you guys are thinking all these molecules floating around, what type of forces are holding these molecules together? The type of molecule, the type of forces are called here dispersion forces. Or London forces. Dispersion forces are also called London forces or van der Waal forces. So you guys have heard about these terms in Chem 1. So we have three types of, these forces are called intermolecular forces. So let me summarize something from Chem 1. Intermolecular forces. So we have three different types of intermolecular forces. Number one is hydrogen bonding. Number two is, anyone? You guys remember dipole interactions? Do you guys remember these terms from Chem 1? You can respond through chat. Do you guys remember these forces from Chem 1? These are called intermolecular forces: hydrogen bonding, dipole interactions, and dispersion forces. So if you guys think about these forces, what type of molecules will contain hydrogen bonding and dipole interactions? Dipole interactions and hydrogen bondings can be found in polar molecules. Dispersion forces are found in non-polar molecules. So alkanes are non-polar in nature. You guys can see these molecules contains carbons and hydrogens, and these molecules are non-polar in nature. So the type of forces that are holding these molecules together is dispersion forces. So what happens to dispersion forces as the number of carbons increases? As the number of carbons increases, the dispersion forces becomes stronger, so the boiling point goes up. So you need to supply more energy to break them apart. Yes? So for example, here, if you take this molecule, this is CH4. The bond between carbon and hydrogen is covalent, but a bond between CH4 molecules is dispersion forces. Now, I also want you guys to remember there is a criteria for hydrogen bonding. Yes, it is available in polar molecules, but not all polar molecules shows hydrogen bonding. Only few molecules which contains OH bond, NH bond, and FH bond are the only molecules that show hydrogen bonding. So the molecule itself must possess OH, NH, FH. The famous example is water. clearly you guys can see in water, water is a polar molecule. So if it's a polar molecule, it contains dipole-dipole interactions. But because of bond, OH bond, this molecule, water molecules also are being held together by using hydrogen bonding. So clearly you guys can see OH, having a OH, NH, FH is a criteria for hydrogen bonding. So please remember that. So once again, let me summarize here about intermolecular forces. Intermolecular forces are the forces that are holding these molecules together. Examples: hydrogen bonding, dipole-dipole interactions, and dispersion forces. Molecules which are polar contains hydrogen bonding and dipole-dipole interactions. But to have hydrogen bonding, the molecule itself must possess OH bond, NH bond, or FH bond. Example, water. If you think about water, if you're trying to break water molecules, if you're trying to boil water, it takes a lot of energy because of hydrogen bonding. Hydrogen bonding is the strongest intermolecular force. So please write down, hydrogen bonding is the strongest intermolecular force. Dispersion forces are the weakest So dispersion forces are the weak intermolecular forces. Okay. So let's continue with the properties of alkanes. So as the number of carbons increases, the melting point, and you guys can clearly see here the number of carbons are increasing. As the number of carbons increases, the melting point and boiling point increases, because the longer chain alkanes have more dispersion forces when compared to smaller chain alkanes, smaller chain alkanes. Now let's look at the branch chain. What happens to when you compare a long chain with a branch chain? So please look at here, we have hexane, and we have 3-methylpentane, and then we have 2,3-dimethylbutane. I want you guys to draw all these three structures in your class notes. I want you guys to draw all these three structures in your class notes. And please write down the names. Please write down the names, and also write down the boiling point. And also write down the boiling point. This is called hexane, and this compound is 3-methyl pentane, and this compound is called 2,3. Why it's 2,3? Because this is a second carbon and this is a third carbon. We have 2 methyl groups on the long chain, so it's 2,3 dimethyl butane. So if you guys are looking at these 3 compounds, what is happening to boiling point? The boiling point is decreasing. Everyone see that? The boiling point is decreasing as the number of branches increases. Now here, look at this compound. This is a straight chain compound. Straight chain compound, and the boiling point is 69 degrees Celsius. When we had a branch, the boiling point went from 69 to 63. If I place one more branch, the boiling point decreased from 63 to 58 degrees Celsius. So why the boiling point is decreasing as the number of branches increasing? Well, please think about how they can stack themselves. So let me go to the whiteboard and explain you guys. So I'm going to clear this. If it's a linear compound, they can stack themselves really nice, and they are more compact. You don't see that? They are more compact. I'm not drawing straight here, but you visualize all long chain molecules. Even if you draw zigzag, okay? Even if you draw zigzag, if they are linear without any branches, you guys can see they can arrange themselves in such a way the dispersion forces can be really intact with each other. Now, what happens if I have a branch? Let's say I have a branch here. Now you guys can see the arrangement is not compact anymore. There is a weak point. You guys can see there is a weak point here at the branch, making it less compact when compared to this long chain molecule. So because of that reason, long chain molecules will have higher boiling point when compared to the corresponding branch chain molecules. So please write down, branch chain alkanes have lower boiling points than straight chain isomers. Branch chain alkanes do not have linear shapes and cannot line up close to each other. That's the main reason. They don't have a linear shape and they cannot line up close to each other. Cycloalkanes. Cycloalkanes have higher boiling points than straight chain alkanes with same number of carbon atoms. So why cycloalkanes have higher boiling point? Because cycloalkanes doesn't have any rotation. Well, there is a limited rotation around carbon-carbon bonds. So they can maintain, when it's a ring, you guys can see they can't really move. Yes, the carbon-carbon bonds, they can't rotate and they can't move. So they maintain their rigid structure and can be stacked closely together. So that gives them higher boiling points. So cycloalkanes have higher boiling point than straight chain alkanes. Next, please, let's compare the boiling points here. The straight chain has pentane has 36 degrees Celsius boiling point. And one branch chain, you guys can see, once you have a branch, the boiling point went from 36 to 28 degrees Celsius. And if you have more branches, the boiling point dropped to 10 degrees Celsius. And the corresponding cycloalkane, same, all these compounds have same number of carbons. All of them have 5 carbons. So this cycloalkane, you guys can see, have a higher boiling point when compared to all these compounds. Next, the next property is called combustion reaction of alkanes. So let me go to whiteboard and explain you guys exactly what is combustion. You guys already know what is combustion. So I'm going to make a statement here. Alkanes undergoes combustion reaction. So because they undergo combustion reaction, so they are what? Flammable. So what is a combustion reaction? So if you take alkene, alkane combines with O2, oxygen gas, in the presence of spark. You know, in our vehicles we have spark plugs, right? So it needs some initiation to start the reaction. So in the presence of spark, produces carbon dioxide. All alkanes produces carbon dioxide, water, and they release tremendous amount of energy. So when you're burning gasoline is releasing a lot of energy. This is the energy we are using to move your vehicle forward. So this is the energy that is being released during the combustion process. So all alkanes undergoes what reaction? Combustion reaction. Because they undergo combustion reaction, they are flammable. So it doesn't matter which alkane you take. You can take, this is a generalized reaction, and you can apply this to CH4, methane, or ethane, or propane. It doesn't matter what alkane it is. So if I apply for methane, how it looks? CH4 plus O2 forms the same products. CO2 plus H2O plus it releases energy. What if I take this compound? I'm going to draw a linear structure. This is an alkane. What if I take this alkane? Yes, it can undergo combustion process with oxygen to release carbon dioxide, water, and energy. And you guys know how to balance these equations. You guys learned balancing chemical equations in Chem 1. So I'm not going to concentrate and show you guys balancing right now, but you guys know how to balance chemical equations. So the main idea here is alkanes undergoes combustion reactions and they are flammable. Okay, I hope everyone got this. If I have to wait, please message me through chat on this screen. So if you're not messaging me on the chat, that means I can go to a different screen immediately. If you need me, if you want me to be on the screen so that you can copy the information, please let me know through the chat. Okay. Okay, now let's look at this table 12.6. If you guys are looking at table 12.6, you guys can see the amount of energy that is, this is the boiling point, and this is a combustion reaction. Every alkane, I don't know why we have this table here. I thought they're showing energies, but they are not energies. Alkane undergo combustion reaction to produce carbon dioxide, water, and energy. So methane is one of the main component in natural gas, and this is a combustion reaction. Propane, we can actually buy pure propane. Propane is a little bit more expensive than natural gas because propane is a pure compound. They have to separate it as a pure compound, so it's a little bit more expensive. And you guys can see this is not propane. I think they made a mistake. It's supposed to be C3H8. So C3H8 reacts with oxygen to form carbon dioxide, water, and energy. So what is the difference between methane combustion to propane combustion? As the number of carbons increases, what is happening to the number of carbon dioxide molecules we are releasing? They will increase. Now think about gasoline or diesel or petrol, how much they are made of 16 carbons. So think about every molecule, how many carbon dioxide molecules were being released into atmosphere. If you go to China or India, there are no regulations. So they just burning kerosene, gasoline like nothing. And those countries are highly polluted. Next, alkanes are non-polar. We saw that because they are non-polar, they are insoluble in water, and alkanes are made of carbon and hydrogen. So they are less dense than water. That's the reason why you guys can see oil is floating on water. Alkanes are flammable, we saw that, and alkanes are found in crude oil. So some of you are thinking, sir, where do we get all these alkane compounds from crude oil? So when you buy crude oil from Arabic countries like Saudi Arabia, when you buy crude oil, you are not only buying gasoline, you are buying a mixture of compounds like methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, and then carbon 11, carbon 12, carbon 13. So you're not just buying one compound, you're buying mixture of compounds. So that crude mixture is being transported from Saudi Arabia to Texas. In Texas, we have a lot of petroleum refineries. We have one in Corpus Christi. If you're driving on the highway, you guys can see on the left-hand side. And also we have a lot of refineries in Houston. So all this crude oil is transported from Arabic countries to these refineries, and these refineries will separate these compounds. They start heating these compounds, this crude mixture, and because all these compounds have different boiling point, they will start separating. So once they start separating, they will collect them as pure compounds and they transport them to our gas stations. So that's the whole process that happens with crude mixture. Next, so I just want you guys to take a minute and read this slide. So let's do the study check. Butane, butane is a fuel often used in lighters. So they want you to write a balanced equation for complete conversion of butane. And I want you guys to take a minute and try to write the equation. And I'm going to show you guys answer in 1 minute. And I want you guys to take 1 minute and try to solve this problem. You guys need to write the equation and then you need to balance the equation. So let's look at the answer for this equation. So the molecular formula for butane, they already gave you guys C4H10. So this is the molecular formula. So when you're writing a chemical equation, we just use molecular formula. Some of you may be drawing structures. You don't need to draw a structure. All you need is a molecular formula. How many carbons and how many hydrogens. So you guys can see the balanced equation here. So 2C4H10 is combining with 13 oxygen molecules to form 8 carbon dioxide molecules and 10 water molecules. Now, why this is a balanced equation? Now, let's check just carbons. 2 times 4 is 8. We have 8 carbons on the left. 8 times 1, here we have 1 here. So 8 times 1 is 8. So carbons are balanced. Hydrogens, please check hydrogens. 2 times 10 is 20 on the left. How many hydrogens we have? 10 times 2 is 20. So when you look at a balanced equation, the number of atoms on the left will be equal to the number of atoms on the right. So that's how we balance chemical equations. Okay, let's start with alkenes and alkynes. Alkene and alkyne. So let's start with alkenes and alkynes. So you guys can see this compound shown here is alkyne. Why it's an alkyne? Because you guys can see there is a carbon-carbon triple bond. There is a triple bond between carbon and carbon. And this compound is called Ethine. Why we call this ethine? Eth means two carbons. So you guys can see this molecule contains two carbons. So it's ethine. Ine represents alkyne. And this compound is widely used. So it has a common name. So it's also called acetylene. And this acetylene gas is used in welding process. So alkenes and alkynes are hydrocarbons that contains double bond and triple bond. And alkenes and alkynes are called unsaturated hydrocarbons. Why we call them unsaturated? Because they do not contain maximum number of hydrogens. So what do they mean by that? So let me show you guys on the whiteboard. So for example, if I take alkane, please look at here, alkane, if I take alkane with two carbons, alkene with a double bond, and alkyne with a triple bond. So all these three compounds contains two carbons. But if you're looking at alkane, how many hydrogens I can place? 1, 2, 3, 4, 5, 6. But in the case of alkene, you guys can see this carbon is already forming two bonds. So I have only two bonds left. 1, 2. And again, on this carbon, I can place only 1 and 2. But because of the triple bond in this molecule, all I can place is 1 here and 1 here. So if you guys are looking at alkane with two carbons, I can place maximum of 6 hydrogens on this carbon. But because of triple bond and double bond, what is happening? The number of hydrogens are very less. Here we have only 4 hydrogens. And in the case of alkyne, we have only 2 hydrogens. That's the reason why these alkene and alkynes are called unsaturated. They don't have maximum number of hydrogens. They do not have maximum number of hydrogens. So alkanes have maximum number of hydrogens on these molecules because they have only carbon-carbon single bonds. So alkanes are called saturated hydrocarbons, and alkenes and alkynes are called unsaturated because they do not hold maximum number of hydrogens. Now, please look at here. Some of the alkanes are very useful to make alcohol. So this molecule, please look at here, this molecule is alcohol. How do I know this molecule is alcohol? Because it contains COH. Everyone see that? In this molecule, we have COH functional group. So if you have alkene, by adding water, we can make alcohol. We are going to talk about this later. Now, ethene is C2H4. Ethene is an alkene. Please take 1 minute and read about this. That's the reason why when you go to HEB, even though the fruits looks ripened, but when you touch them, they are Rock as solid. Solid as a rock. Because they just use this gas to ripen all these fruits to make them look good. So identifying alkynes, how do we identify alkynes? By just looking at carbon-carbon triple bond, carbon-carbon triple bond. So let's do the study check here. Please send your answers through chat. What do you guys think about A and B? Identify each of the following compounds as an alkene and alkyne. So please send your answers through chat. Very few people are responding. Everyone needs to respond. So A is what? Because this molecule contains a double bond, A is alkene. And if you're looking at this molecule, because of triple bond, just one triple bond, it becomes alkyne. Now let's look at the naming of alkenes and alkynes. We are going to look at the naming of alkenes and alkynes. And I'm going to do this on a whiteboard. I'm going to do this on a whiteboard. So let's solve some problems on a whiteboard. Now let's look at here. This is alkane. If I place a double bond, what happens? This becomes alkene. This is alkyne. So all these three compounds contains how many carbons? 3 carbons. So let me show you guys 3 carbons. 1, 2, 3. 1, 2, 3. 1, 2, 3. So you guys can see all the dots. Those dots represents carbons. So what is the name of this compound? Because this compound contains all single bonds and it belongs to a family called ane. So the name of this compound is propane. Why it's prop? Because it contains 3 carbons. It contains 3 carbons. And the name of this compound is pro because of 3 carbons, prop. But it belongs to a family called ene. So the name of this compound becomes propene. You guys can see from alkene, I'm taking ene. So it becomes propene. And the name of this compound is propine, because this is a alkyne. So it's propine. So we have a propene and propine. we are going to look at more complex molecules. But simple molecules are very easy. Long chain molecules. These are long chain molecules. They are very easy to name. You have propane, propene, and propine. So now let's look at some complex molecules. For example, so let's try to name this molecule. So the basic rule is find the longest carbon chain. It doesn't change. That's what we did yesterday. Longest carbon chain. We always has to find the longest carbon chain. So where is my longest carbon chain? The longest carbon chain is here. This is my longest carbon chain. Now, in the longest carbon chain, how many carbons we have? 1, 2, 3, 4, 5, 6. So if you have 6 carbons, what is the last name it's going to be? The last name is going to be hexene. The last name is going to be hexene. Yes. Now, we need to number this chain. We need to number this chain. So the rule changes slightly from alkanes to alkenes. This time, we have to start numbering from the end close to the double bond, not to the substituent, close to the double bond. Why it has to be close to the double bond? Because that double bond signifies this compound, what it is. So you have to start numbering from the end close to the double bond. So if you guys are looking at this double bond is close to this end. This double bond is close to this end. So if it's close to this end, can I start numbering from this side? Yes, so let's start doing that. So this carbon gets 1. This is 2, 3, 4, 5, 6. Now, what is the location of a double bond? We also need to find the location of a double bond, where the double bond is starting from the numbers. It's starting from 2 and it's ending at 3. So the name becomes not just hexene, it's 2-hexene. So you also have to show the location of a double bond. The location of a double bond is starting at 2. So we know exactly where to place double bond. It's 2-hexene. Now we can look at the location of a substituent. Where is the substituent? Where is our branch? It's on carbon number 5. So the name of this compound becomes 5-methyl and 2-hexene. 5-methyl 2-hexene. So you guys can see the suffix is again naming the substituent. Sorry, the prefix is naming the substituent, and the suffix is the location and the name of the longest chain. So the prefix is location and name of the substituents. and suffix is location and the name of the longest chain. So what happens if you have more than one substituent? Well, you just have to place them in alphabetical order, just like before. So you guys can see when you have a alkene, alkene, or alkyne, again, you have to find the longest carbon chain and you have to start numbering from the end close to the double bond. You have to start from the end close to the double bond. But that's not what we did with alkanes. Alkanes, we started from the end close to the substituent, right? But in the case of alkene, you have to start from the end close to the double bond. And then everything else is same. The prefix is the location and the names of the substituents. And the suffix is the location. You have to give the location of the double bond. Here, 2 represents the location of the double bond and the name of the longest chain. And the name of the longest chain is hexene. Now let's do an example. If you guys have any questions, please let me know. Sorry, this is really bad. Drawing with mouse is very hard. Now let's try to name this compound. Clearly, you guys can see this compound contains a double bond. So it has to be alkene. It has to be alkene. Now, what we are going to do is we are going to find the longest carbon chain. The longest carbon chain is this. I'm not including chlorine because chlorine is not carbon. This is my longest carbon chain. So if this is my longest carbon chain, from where we have to start numbering? I have to start numbering from the end close to the substituent, So, sorry, close to the double bond. So where is my double bond? Here is my double bond. If I start from this end, it's 1, 2. If I start from this end, it's 1, 2, 3. The double bond is starting at 3. So I need to start numbering from this end. So it's 1, 2, 3, 4, 5. So on 5, you guys can see I have a branch called chloro. So Cl is called chloro. I have only one branch. So the name of this compound becomes what? 5-chloro. 5-chloro 2. Why 2? Because this is the location of the double bond. That's where it's starting. If you don't place the location, then we don't know the double bond, where it is. So we need to show the location of the double bond. So it starts at 2. 2. How many carbons we have in the long chain? 5. So we have 5. So it's pent. 5 pent. Because of the double bond, it becomes ene pentene. So the name of this compound is 5-chloro 2-pentene. 5-chloro 2-pentene. So everything is same except numbering. Everything is same as alkanes except numbering the long chain. The long chain has to be numbered from the end close to the double bond. Close to the double bond. Now try to name this. And you guys can send me the answers through chat. Try to name this compound. And you guys can send me the answers to the chat. So someone is asking me, what if we have a methyl with it? So if you have a methyl, then it becomes 5-chloro, and the location of the methyl, let's say the methyl is here, 4-methyl 2-pentene. Just in alphabetical order. If you have more than one substituent, just like alkanes, place them in alphabetical order. Now please solve this and try to send me the answer through chat. Find the longest carbon chain and name all the branches, place them in alphabetical order and complete the name.
All of a sudden, everything's working good in there with the TV. It was a whole. And the Wi-Fi, you think there's a. Money.
So let's look at the answers. Some of you send me the answers. So let's look at the answers for this. So this is my longest carbon chain. Clearly you guys can see this is the longest carbon chain. And if this is the longest carbon chain, from which end I have to start numbering? From this end, because the double bond is more close to this end than this end. So 1, 2, 3, 4, 5, 6, 7. So if you have 7, 7, and the location of the double bond starting at 2, so it's going to be 2-heptene. It's going to be 2-heptene. That's our suffix. And I think most of you got this, 2-heptene. Now let's look at the branches. This branch is called bromo. This branch is called bromo. And these are the branches called methyl groups. Everyone see that? This is a carbon. You have only one carbon here. So this is methyl, and this is methyl. So you have only one carbon. So it's methyl groups. And the location is what? 4 and 6. Yes. And then we have bromo at 5. So the name of this compound is in alphabetical order, 5-bromo. In alphabetical order, B comes before M. So 5-bromo. Now we have 3 methyl groups which are same. So I can use trimethyl instead of being redundant like methyl, methyl, methyl. Yes. So it's trimethyl. And the location is 4, 6. So 4, 6, 6. Trimethyl. You guys can see it's a little bit hard for me to write. Trimethyl 2-heptene. 2-heptene. And some of you are thinking, sir, how come this is not ethyl? Why this is not ethyl? Now, let me show you guys why it's not ethyl. Please look at here. If you're confused about methyl and ethyl, I'm going to show you the difference. This is 2 methyl groups. This is ethyl. It has to be in one chain to be ethyl. So this is ethyl. And this is 2 methyls. There is a difference. These two are 2 branches on the same carbon. You have 2 branches on the same carbon. Here you have 1 branch, which is a long chain. So it's CH2, CH3, it's ethyl. Okay. So you guys can see the name of this compound is 5-bromo 4, 6, 6 trimethyl 2-heptene. If you got this, you are right. Now let me clear this. Now let's look at cyclic alkenes. Now we are going to look at cyclic alkenes or cycloalkenes. So cycloalkenes. Cycloalkenes, please look at here. This is butane. But if I place a double bond inside, it becomes cyclobutene. This is cyclopentene. And this is cyclohexene. So this is cyclo. You have to use the prefix cyclobutene, cyclopentene, and this becomes cyclohexene. So you guys can see the difference from cycloalkanes to cycloalkenes. Now, what happens if I have a substituent? What happens if I have a substituent on these rings? So please look at here. So let's take this compound, cyclopentene. I have a double bond. So what if I have a methyl group? What happens if I have a methyl group? Can you guys guess the name of this compound and send me the messages in chat? Can you guys guess this and guess the name of this compound and send me the messages? Please try to send me the answers in the chat for this compound. What do you guys think is the name of this compound? Anyone? Yes, most of you are sending me the answers. Yes, yes. It's 3-methyl. Yes, it's a 3-methyl. Why it's methyl? Because this is a cyclic structure. This is a cyclic structure. You have to start numbering, even though you have only one substituent, you still has to start numbering um, because you have to give the numbers to the double bonds. So please look at here. If I give one here, I can go clockwise or counterclockwise. If you give one to this double bond, the next carbon with the double bond has to get 2. Please remember that. When you're numbering a ring, when you're numbering a ring, if one double bonded carbon gets 1, the second one has to get 2. You can't go this way. You can't give 2 to this carbon. Why? Because this carbon doesn't have a double bond. This is the carbon which has a double bond. So if I give 1 to this has to be 2 and this will be 3. And what if I go like this? Please think about this. Most of you got it right. What if I have like this? What happens if I give 1 to this? If I give 1 to this, then this has to be 2. If this is 2, then this one has to be 3, 4, 5. So the logical thing to do is this. Why? Because the substituent has to get the lowest number. Please look at here. This is a low number for this. But if I go clockwise, I get 5 for this. If I go counterclockwise, I can give 3. So the name of this compound is 3-methyl 1-cyclopentene. Some of you are thinking, sir, do I need to place 1? No, you don't need to place 1. By default, we know it's at 1. You can place 1 or you can just ignore 1. It doesn't matter. By default, even if you don't place 1, we know it's starting at 1. Okay, 1 is like optional. You can place it or ignore it. So the name of this compound is 3-methyl 1-cyclopentene, or simply 3-methyl 1-cyclopentene. So please remember this. If you give a number to one double bonded carbon, the second double bonded carbon has to get 2, not the other way around, not this way. This is wrong. The reason why this is wrong is because the substituent here is getting the lowest possible number. Okay. Sabas, are you getting this? Are you following the lecture?
Yes, sir. You answered my question.
Okay. Now, please try to solve this. Please try to name this and send me the answers. Try to name this compound and send me the answers. Okay, so let's look at the answers. No, Savas is asking me if we have to use hyphen between prefix and suffix. No, ma'am, we don't need to. So let's look at the answer for this. So where the question is, when you are trying to solve this, you're thinking where I can start this. Is this carbon going to get 1 or this carbon going to get 1? Well, most of you thought this is the carbon which is going to get 1, but that's not the truth. That's not the case here. This is the one which gets 1, and this is the one which gets 2. Why? Because if you can't able to decide by the double bond, you have to decide the location by using a substituent. Please look at here. If I place 1 here and 2, let me draw the other option for us here. Yes, it is tricky. If I gave 1 here and if I gave 2, look at the substituent is getting 2. But if I start here, substituent can get the lowest number. The substituent can get the lowest number if I start here and give this to 2. So this is wrong. The substituent, the rule in cyclic structures is the substituent has to get the lowest possible numbers. So the answer for this is 1-methyl cyclobutene. 1-methyl cyclobutene. Please remember, in the ring, the substituents has to get you always has to keep this in mind. So the answer is 1-methyl. It's not 2-methyl, it's 1-methyl cyclobutene. Okay, next one. Please try to solve this. And you guys can send the answers through chat. Some of you are missing the prefixes like di, tri, tetra. Please make sure you use that. So when you don't send me messages through chat, that tells me that you're not being participant of the class. So please solve and try to send me the chat messages. In remote learning, this is the only way we can track who is participating and who is not participating. So the answer is where we have to start numbering here. Where we can start numbering here, this carbon or this carbon. I have to start numbering from here. Why? Because if I start from here, I can give the lowest possible number to this substituent. So this is 1. If this is 1, this has to be 2 because this is a double bonded carbon. You can't go the other way. So this is 2, this is 3, and this is 4. So the name of this compound is 1, 4, 1, 4 dimethyl cyclohexene. A lot of people are thinking it's hexane. It's not hexane, it's hexene. So 1, 4 dimethyl cyclohexene. There is no hyphen between dimethyl and cyclo. You have to combine them together. So it's 1, 4 dimethyl cyclohexene. There is no hyphen between, because the hyphen is used only between numbers and name. Look at here, between 4 and the name, I used hyphen. You don't use hyphen between name and name. You have to use hyphen only between number and name. If you look at the rule from last class, we use comma between the numbers. Please look at here, I used comma between 2 numbers. I used a hyphen between number and name. But here, these are 2 names. You don't need to use hyphen or comma or anything. Okay. Okay, now let's solve a couple of problems on alkyne. So let's solve some problems in mastering chemistry. Let's solve some problems in alkyne. So let's do this. So please solve this and send me the answers in chat. I would like to draw a little bit much better here. Please let's look at here. Please try to name this and send me the answers in chat. Okay, let's look at the answers. Everyone, please send me the answers through chat. Okay, let's find the longest carbon chain. The longest carbon chain is this. This whole thing is the longest carbon chain. Even though it's drawn differently, but if you're looking at this, you guys can see this carbon is connected to this carbon is connected to this carbon, and so on. So let's find out how many carbons we have here. This is 1. This is 2. A lot of people miss this. Triple bond, wherever there is a triple bond, there is a carbon. That's 3. Wherever the triple bond ends, there is a carbon, 4. And this is the intersection point, 5. And this is 6. So a lot of people missed this carbon where the triple bond started and this carbon where triple bond ended. You have to be aware of this. Wherever the triple bond starts, there is a carbon, and wherever the triple bond is ending, there is a carbon. So this is not 4 carbons. How many carbons we have here? 1, 2, 3, 4, 5, 6 carbons. Now, once you know all the carbons, from which side I have to start numbering? Numbering from the end close to the triple bond. This time it's close to the triple bond. When you're trying to draw close to the triple, looking for the end close to the triple bond, if you look at from this end and from this end, it's at the same location. So it doesn't matter. So let's start from here. 1, 2, 3, 4, 5, 6. So if you have 6 carbons in the long chain and the triple bond is starting at 3, even if you count from this side, it's going to start from 3. 1, 2, 3. So it doesn't matter from which side you start counting. So the name of this compound is 3-hexyne. So if you got this, you got it right. 3-hexyne. 3 represents the location of that triple bond. That's where it's starting. It's a 3-hexyne. A lot of people missed carbon number 3 and carbon number 4. Please be aware of the carbons at the beginning of the triple bond and at the end of the triple bond. You have carbons. Now let's do one more example. Can you guys guess this name? Please try to solve this and send me the answers. I know this is a tough one, but let me solve this. If you guys are thinking, you guys can see this is my longest chain. This is it. I don't have anything else. I have 2 carbons, and if this is the longest chain, now I have to use this as a substituent. There is no other way I can get into ring. So this is called cyclopentyl. This is cyclopentyl as a substituent. The longest chain is 1, 2. So the name of this compound is 2-cyclopentyl 2-cyclopentyl ethine. 2-cyclo, on 2 you have a group. On 2 you have a group I'm using as a substituent, just like methyl, ethyl, propyl. This is cyclopentyl. Just like methyl, ethyl. So some of you are thinking why the ring is not the longest carbon chain. Well, if you have alkane ring, and then if you have alkene and alkyne dominates alkane. The ring will never be, alkanes will never be the dominant functional groups because they are the backbone of all the molecules. They are the backbone. Yes, in a ring you have 5 carbons. In alkene here you have only 2 carbons, but still alkynes take precedence over the ring because alkanes are the backbone of these molecules and they don't play a significant role. Alkenes and alkanes plays a significant role. So that's the reason why we use ethyne. Why it's ethyne? Why it's ethyne? Because you have, eth means what? 2 carbons. Ine means triple bond. Why it's pentyl? Okay, why it's pentyl? So some of you are thinking why it's pentyl. So look at here, 1, 2, 3, 4, 5. That's the reason why it's pentyl. And why it's cyclo? Because this is a cyclic structure. Why it's ethyne? Because I have 1, 2 carbons, so it's eth. Ine because of triple bond. Okay, I'm not going to give you guys hard questions like this. Okay, I mean most of them are going to be straightforward. Now let's solve some problems from your textbook. Please open page number. Please open page number 443. Page number 443. Try to solve 12.25. Try to solve 12.25, 12.27, 12.29. Once you guys are done with these problems, if you guys want me to solve any problem on the whiteboard, I will do that for you. But I want you guys to try these problems. Page number 443, 12.25, 12.27, and 12.29. I want you guys, I want everyone to try these problems first. 12.25, 12.27, and 12.29. I want you guys to try to solve these problems right now. And if you guys have any questions, I will solve it on the whiteboard later once you try them. So you have, it's 10 o'clock. It's, let me give you guys 15 minutes on these problems. You have 15 minutes to solve all these problems. Okay, let me see here. Do you guys want me to solve any problem from 12.25? 12.25. If you want me to solve any problem from 12.25, please send me a message. Okay, so nobody wants me to solve 12.25. What about 12.27? 12.27. I think I'm seeing someone is asking me to solve 12.27C. Okay, someone is asking me to solve 12.27C. While I'm solving it, if you want me to solve more problems from that problem set, please let me know. So let's solve 12.27C. .27C. So let's draw the structure. This is pretty simple one, unless you have a wrong answer in your textbook. Okay, someone also wants me to solve B, so let's look at that too. Okay, the answer for this is ethyl group. Everyone see that? This is ethyl group, clearly. And let's look at the numbering here. If I give this 1, and this will be 2, this will be 3, and this will be 4. So the answer is 4-ethyl cyclopentene. If you see any other answer in your textbook, that means it's just a printing mistake. 4-ethyl cyclopentene. This is the answer for 12.27C. Well, can I switch 1 and 2? Can I give 1 to this double bonded and 2 here? Yes, you can do that. 1, 2, 3, 4. It doesn't change the position, so it doesn't matter. Yes, you can switch 1 and 2. You can give this 1 and this 2. Well, why don't we say 1 cyclopentene? Because as I told you before, 1 can be by default. You can use it or you can ignore it. Yes, you can either use 1 or you can ignore 1 in cyclic rings. Okay, now let's move on to 12.27B. I'm looking at 12.27B. So if I'm looking at this compound, I want to find the longest carbon chain, but I want to find all the carbons first. So this is my carbon here. This is my carbon. There's a carbon here. There is a carbon, and there is a carbon. So my longest carbon chain is this, all the way coming down. That's my longest carbon chain. Now I have to start from the end close to the triple bond. If I start counting from here, it's 1, 2. But if I start counting from here, 1, 2, 3. So this end is much more closer. So this is 1. This is 2. This is 3. This is 4. And this is 5. So the name of this compound, clearly you guys can see this. 4-bromo. I have to use a hyphen between number and name. 4-bromo 2, that's where I'm starting triple bond, 2-pentene, 4-bromo, 2-pentene. 4-bromo, 2-pentene. Oh, I'm sorry. Yes, you're right. I'm sorry. This is not pentene. It's pentyne. Yes, thank you. 4-bromo, 2-pentyne. I'm sorry. It's not a double bond. It's a triple bond. So it is 4-bromo, 2-pentyne. Yes. So what about 12.29? 12.29. Okay, so let's solve D. 12.29D. So the name that they gave us is 3-chloro, 1-butene. Butene. So clearly it contains a triple bond. 3-chloro, 1-butene. So where is my longest carbon chain? The longest carbon chain is this, but. So I'm going to place 4 carbons. But means 4 carbons. So I'm going to place 4 carbons. So once I have 4 carbons, I'm looking at the last name. The last name is ine triple bond, and the location of the triple bond is at 1. So on 1, I'm going to place a triple bond. That's my triple bond on 1. And if this is 1, this will be 2, and this is my 3. On 3, I have a chloro. So I'm going to place chloro, Cl. So now I have everything done. All I have to do is now fill up hydrogens. How many hydrogens I can have here? 1, because that carbon is already forming 3 bonds. Here, I can't have any hydrogens on this carbon because it already has triple bond here and then 1 more here. So there is no more hydrogens. On this carbon, I can have 1 hydrogen. And on this carbon, because it's forming only 1 bond, I can have 3 hydrogens. So this is the structure. Yes, you can also draw line angle formula. It doesn't matter. Here I chose to go with the condensed, but if you want to draw line angle, this is how it looks like. So first to draw a triple bond, and then go straight. It has to be straight because the 4th triple bond cannot bend. So you have to draw a straight line here. This is my 3rd carbon. On the 3rd carbon, you have chlorine. So this is here. And this is here. Why I'm going straight? Because triple bond cannot bend. So this is my triple bond, I mean that carbon, and this one is here. So that's the line angle formula. So do you guys want me to solve any other problem from 12.29? I really don't know what they had as an answer. Let me look in the textbook. 12.29, what they had in the answer. Oh, I mean, it's the same thing. They just They just have drawn differently. That's it. 1, 2, 3, 4, 5, 6 carbons. They have 6 carbons. But the name says butane, but they have 6 carbons in the answer. So they are wrong, ma'am. It's a printing mistake. It's a printing mistake. It's supposed to be different name, but I think, yeah, the D is wrong. Yes, you're right. The answer that they had is wrong for D in your textbook. Okay, now we are done with this topic. Now the next topic is cis and trans isomers. So what is cis and trans isomers? Let me explain this before I get into the PowerPoint. Now let me take an example here. If I take a carbon-carbon double bond, and if I take a carbon-carbon single bond and a double bond, there is a major difference between these two compounds. If you're looking at single bond, there is a free rotation happening around carbon-carbon single bond. There is a free rotation around carbon-carbon single bond. But when you're looking at a carbon-carbon double bond, on carbon-carbon double bond, so when you have a free rotation, what is happening to the remaining bonds? They are constantly changing their positions. Everyone see that? These 6 hydrogens are constantly changing their position when there is a free rotation around carbon-carbon single bond. But when you're looking at carbon-carbon double bond, there is no free rotation around carbon-carbon because this double bond kind of blocks the rotation. So when there is no free rotation around carbon-carbon double bond, when there is no free rotation around carbon-carbon double bond, the positions of hydrogens, they can be hydrogens or they can be substituents, it doesn't matter, is fixed in space. You guys can see the position of these substituents here, one here, one here, one here, and one here. These positions are fixed in space. When these positions are fixed in space, what happens is that leads to cis and trans isomers. So the only compounds that can form cis and trans isomers are alkenes. Not alkanes, not alkynes. So the only ones which can form cis and trans isomers are alkenes. So let me explain you guys by taking an example. Please look at here. Let me erase this. Let's look at this example. If I take this compound, look at here, because there is no free rotation, the position of these substituents are already fixed in space. And that leads to cis and trans isomers. Let me show you guys the way I think. Everyone, please look at the video here. Now think about this as a double bond, okay? This as a double bond. Everyone, please look at here. This as a double bond, and these are the substituents. Yes, these are the substituents. Oh, let me put it the other way. What about this? This is my double bond. This is my double bond, and here we have substituents. If the high priority substituents are on the same side of a double bond, then it's called cis. If they're on the opposite side of a double bond, then it's called trans. If my fingers are double bonds here, please look at here, these are double bonds. If the substituents are on the same side of a double bond, then we call cis. If they're on the opposite side of a double bond, then they are called trans. So because of restricted rotation in around double bond, you have cis and trans isomerism. So let me open the PowerPoint and we will discuss about cis and trans. So let me share a PowerPoint with you guys and then we can look at it. Okay, now look at here. Now please look at here. These are cis hands. Everyone see this? You guys can see the thumbs and then fingers. If your fingers represents a double bond, and because of the restricted rotation, if the substituents, if the thumbs are on the same side of a double bond, then they are called cis. If they're on the opposite side of a double bond, they are called trans. And I'm going to show you guys by taking an example. Now, please look at this example. Look at this example. Please look at here. This is cis butene. Why this is cis butene? You guys can see this is a methyl group and this is a methyl group. These are the top priority groups. If the top priority groups are on the same side of a double bond, then they are called cis. If they are on the opposite side of a double bond, then they are called trans. So how do we decide which one is a high priority group? So let me show you guys on the whiteboard. Let me show you guys on the whiteboard here. So let me draw. I want everyone to visualize like this. So you guys can see this carbon has 4 bonds, this carbon has 4 bonds. If the high priority you guys can see if the high priority groups, so between this group here, you have some group here, and you have other group here, but this is the high priority group. If the high priority group on this carbon, and if the high priority group on this carbon are on the same side of a double bond, you guys can see they both are on the same side of a double bond, then it's called cis. Now, let me show you guys the trans. Now you guys can see the high priority groups are on the opposite sides of a double bond. One is facing up, other one is facing down here on this carbon. So between these, on this carbon, between these two groups, this is a high priority. And between these two groups, this is a high priority. If the high priority groups are on the opposite side of a double bond, then they are called trans. You guys heard about the name trans fat. This is what it's coming from. It's coming from trans. So when you use the word trans, what you are thinking from chemistry point of view is carbon-carbon double bond, and the high priority groups are on the opposite side of a double bond. Now, let me show you guys an example. How do we decide which one is a high priority group? High priority is given so high priority groups are atoms with higher atomic number. So if the atomic number is higher, then it becomes higher priority group. Let me show you guys an example on that. Now, let's take this compound. I'm actually placing the groups right now. Now, please look at here. So what is the atomic number for chlorine? We all know the atomic number for chlorine. Chlorine is 17 and hydrogen is 1. So clearly between 17 and 1, which one is a high priority group? Which one is a high priority group? Chlorine is a high priority group on this carbon. On this carbon, chlorine is a high priority group. Well, what about this carbon? On this carbon, again, we have chlorine with atomic number 17 and hydrogen 1. So you guys can clearly see the high priority groups are on the same side of a double bond. So this is cis and this is trans because they both are on the opposite side. So high priority groups are atoms with higher atomic number. Atoms with higher priority. High priority groups are atoms with higher atomic number. Now I'm going to show you guys how to draw cis and trans in line structure. I'm going to draw this in the line structure. So please look at here. Okay. Yes, so some of you are thinking, what if the CL here, if this CL is on the bottom? Yes, it's still cis. The definition for cis is priority groups has to be on the same side of a double bond. It can be both facing up or both facing down. It doesn't matter. Yeah, it doesn't matter. If you place these two chlorines on the bottom, they're still cis. If you place these two chlorines on the bottom, they are still cis. Okay, now please look at here. I'm going to show you guys how to draw this in a line structure. In the line structure, this is how it looks. This is cis. Now look at how trans looks like. In line structures, we don't show hydrogens. So everyone see the difference between drawing cis and trans? Everyone see the difference between drawing cis and trans? So when you draw the line structures, you guys can clearly see the high priority groups are on the same side of a double bond. Then it's cis. And if they're on the opposite side of a double bond, then they become trans. Now let me give you guys an example. Well, let me give you an example here. Okay, let's take this double bond. Now please send me the answers. Is this cis or trans? Please send your answers through the chat if this is cis or trans. Yes, let's analyze this. Let's analyze this on, this is the double bonded carbon. And this is my double bonded carbon. And I want to find out between these two groups, which one has a high priority. Well, the atomic number for hydrogen is 1. And the atomic number for carbon is what? 6. Everyone see this? Some of you are thinking, what about these hydrogens? These hydrogens are not on this carbon. These hydrogens are on this carbon. So this is the carbon directly attached to this carbon. So the atomic number for this carbon is 6. So between 6 and 1, clearly you guys can see this is the high priority. And between these two, this is 1, atomic number is 1. This atomic number is 6. So this is a high priority group. So the high priority groups are on the same side of a double bond. So this is cis. And if I have to name this compound, you're not adding the atomic numbers for both. You're just looking between 6 and 1, which one has higher atomic number. Your goal is to find out the high priority group by comparing the atomic numbers. So I'm just comparing 6 and 1, and I'm saying 6 is higher than 1, so 6 is high priority. And between these two, 6 is higher than 1, so this group is higher priority. And the high priority groups are on the same side of a double bond, so this is cis. Okay, so if I want to name this compound, how do I name this compound? So let's name this compound. Now we know this is cis. How do I name this compound? Well, again, the rules are same. Find the longest carbon chain. So this is my longest carbon chain. That's my longest carbon chain. Now I have to start numbering from the end close to the double bond. So it doesn't matter. So 1. Here it doesn't matter. 2, 3, 4. So the name of this compound is 2,2-butene. I don't have any substituents. So this is 2-butene, but this structure looks like in the form of cis. So you also add the prefix cis. So the name of this compound is cis-2-butene. So the name of this compound is cis-2-butene. So this compound is same as this. Please look at here, CH3. I can draw the above compound like this. It's the same thing. This compound is same as this compound. It's the same structure, same molecule. I have drawn this molecule in the form of cis. So the name of this compound is cis-2-butene. If you see in the form of a trans, then it becomes trans-2-butene. So if I have to draw the trans, this is going to look like this. So the 2 is the location of the double bond. The double bond is starting at 2. That's the reason why it's 2-butene. So if you're looking at this, this is still my longest chain. This is still my longest chain. But this time, the high priority groups are on the opposite side of a double bond. So 1, 2, 3, 4. They're all connected in a series. 4. So the name of this compound becomes what? Trans-2-butene. So you guys can see this compound can be drawn either cis or you can draw them as a trans because of restricted rotation around the double bond. So the only compounds that can display cis and trans are alkenes. Alkenes. The only compounds that can that can display cis and trans isomerism or alkenes. Now, let me give you guys yes, the two is that's where because the double bond starts. Yes. Okay, now let me give you guys a question here. Can you guys tell me if this is cis or trans? Please send me the messages through chat. Can you guys find this structure if this is cis or trans? And also I want you guys to name this. Please find out if this is cis or trans. Some of you are thinking high priority groups has to be same. No, they don't need to be same. They can be two different ones. Some of you are thinking this is neither. I don't see the same groups on the same side. That's not the definition for cis. What I said, cis is a compound where high priority groups are on the same side. I never said same groups. I said high priority groups are on the same side. So this, please, let's assign the priorities first. What is the atomic number for bromine? Oh, 35. What is the atomic number for carbon? 6. Chlorine is 17 and 1. Hydrogen is 1. So when you assign the priority now between 6 and 13, which one is higher? Which one is a higher number? 35 is higher than 6. So between these two groups, bromine is a high priority group. Now look at 1 and 7, 1 and 17. Between 1 and 17, which one is a high priority? Higher number, 17. So chlorine is a high priority group. Now you guys can see the high priority groups are on the same side of a double bond. So this is cis. This is cis. Now I want you guys to name this compound. Can you guys name this compound? We know this is cis. Can you guys name this compound and send me the answer through messages? Can you guys name this compound and send me the answers through the messages? The rules are same. You just have to find the longest carbon chain and apply the same rules, and then you just have to add cis in the front. Look at here. I think most of you are having a hard time solving this. Let me solve this. So I'm finding the longest carbon chain. Where is my carbon chain? This is a carbon, this is a carbon, this is a carbon. They're all connected in a series. So this is my longest carbon chain. That's my longest carbon chain. Now I have to start numbering from the end. I have to start numbering from the end close to the double bond. If I start from this end, it's 1, 2. If I start from this end, it's 1, 2. So I can start exactly on the double bonded carbon. So it's 1, 2, 3. So by starting here, I get the lowest number for the double bond. This is the closest. That's 1. Now I can clearly see my substituents. Everyone see that? My substituents are bromo and chloro. Bromo and chloro. And this is cis. So the name of this compound is cis in alphabetical order. 1 bromo in alphabetical order. Oh, I'm sorry, it's not 1, it's 2 bromo. 2 bromo, 1 chloro, 1 chloro, 1. I can use 1 or you can ignore 1 by default. If you're not placing any number there, that means it's 1. Okay, so you can place it or you can ignore it. So 1 propene. So the name of this compound is cis 2 bromo 1 chloro 1 propene. Okay, now let's solve one more problem. What about this compound? Is this cis or trans? Is this compound is cis or trans? Is this compound is cis or trans? Most of you are thinking it's trans. I want you guys to think about it. If the high priority groups are on the same side, it's cis. If the high priority groups are on the opposite side of a double bond, then it's trans. So please send your answers through chat. Okay, let's assign the priority groups. The priority group here for hydrogen, it's atomic number 1. It's also 1. If they both have the same atomic number, is it possible to decide which one is a high priority? No, because on this side, they both have the same atomic number. Between these two groups, I can't really decide which one has a high priority. So the answer is so this compound is neither cis nor trans. because we can't really decide between these two groups which one is a high priority group. Okay. Now look at this compound. If you're looking at this compound, this is a compound produced by the female silkworm. Now clearly you guys can see within this compound you have trans double bond and then you have cis double bond. You guys can see the nature makes both types of double bonds, trans double bond and cis double bond. Why this is cis double bond? Because you guys can see this bond is facing down and this bond is facing down. They both are on the same side. So this is cis. On this double bond, one is facing down, other one is facing up. So this is trans double bond. Clearly, you guys can see the bonds are facing up. They both are facing up or they both can face down. But in the trans, what do you see? One bond is facing down, other bond is facing up. So this is trans. And this is cis. So the name of this compound is cis 1,2 dibromo. Why? This is bromo, dibromoethene. This is trans 1,2 dibromoethene. When you draw the line structures, you guys can clearly see the difference between a cis double bond and a trans double bond. Please solve this and send me the answers through chat. All these PowerPoints are available in Canvas under modules. Under modules, each chapter has PowerPoints. Every chapter has PowerPoints. Please send the answers. Everyone, please send the answers for A, B, and C. Try to find if they are cis or trans and then solve them and by name them and add cis or trans prefix. I'm still waiting from a lot of people to send me the answers. Please send the answers for A, B, and C. So clearly you guys can see A is cis, B is trans, and C is trans. Okay, let's look at the answers. The answers are cis 2,3 dichlorobutene, trans 2,3 dibromobutene, and the C is trans 2-butene. There are no substituents on C. We have only one long chain. So it's 2-butene, but it's in the form of a trans, so it's a trans 2-butene. Point 31B. So let me solve 12.31B. 12.31B. Okay, let me share a whiteboard. Okay, now let's look at this B, 12.31B. I'm going to draw just the line structure because it's easy for me to draw through by using my mouse. So let's do that. First, I'm going to start with a double bond. It clearly looks like it's a trans double bond. If it trans, I have to place one bond down, one bond up in the line structures. And when I place up, I have only 2 carbons. So 1, 2 on this side. So that's B. So here we have 1, 2, 3, 4, 5, 6, 7, 8. So the name of this compound is trans. Clearly I can see it's a trans 3, because why is 3? Because if I count from this side, it's the double bond is starting at 3. If I count from this side, 1, 2, 3, 4, 5. So the lowest number is 3. So trans 3. If you have 8 carbons, that's octene. Trans 3 octene. So 12.31B is on the board. Now, do you guys want me to solve any problem in 12.33? If you need any help on any of those problems, how to approach them, please send me a chat message right now. Okay, so let's solve 12.33c. The hydrogens have only the between them. Please look at here. Let me show you guys hydrogens. Why I think this is cis, because some people are still confused why this is trans. So let's do that. Some people are thinking the hydrogens are on the opposite side, so this is supposed to be trans. But that's not the case. I have to look at between this group and this group. And I have to look at the priority between this group and this group. So here I have a carbon, so the atomic number is 6. Here I have 1. Here this is 1, this is 6. Yes, just go by 6. Yes, just go by 6. Carbons are 6. So between 6 and 1, which one has the top priority? 6. Between 1 and 6, which one has the top priority? 6. So they both are on the opposite side, so it's a trans. Now let me solve 12.33. 12.33. Someone asked me for C. So let me solve C. So the name is cis-4-octene. So let me write down the name here. Cis-4-octene. Oct means 8 carbons. That's my longest chain, oct. Ene represents a double bond, and 4 is the location of the double bond, and the double bond has to be cis. So please look at here. I know cis means what? Cis means they both has to be same side. I'm drawing down. If you want to draw up, it's your choice. I'm drawing down. But if you want to draw up, you can draw up. So this is 4. If this is 4, this has to be 5. Why I'm placing 4 and 5 there? Because the location of the double bond starts at 4. So this is 4. This has to be 4. And this has to be 5. Now all I have to do is go back and fill up 3, 2, 1 on this side. So this is 3, 2, 1 on this side. And fill up 6, 7, 8 on this side. 6, 7, 8. So when I'm drawing a structure for alkenes, cis and trans, I would start with a double bond. If it is cis, I will face them down or both face them up. It's up to you. If it's trans, I will draw opposite bonds and I will expand on it. That's it. Any other questions that you guys want me to solve? Now let me solve 12.33a just to do it so that you guys can get some practice out of it. 12.33a. The name is trans 1-bromo 2-chloroethene. Ethene means what? Ethene means only 2 carbons. That means 2 carbons. That's it. This is a 2 carbon. But it has to be trans. Trans means I can draw opposite bonds, 1 bond facing up, one bond facing down. So on 1, you have bromo. So if this is 1, this has to be 2. On 1, I can place bromo. On 2, I can place chloro. Everyone see how I'm thinking about cis and trans? If it is cis, I'm drawing both bonds down, or you can draw up, both up. It doesn't matter. But if it's trans, I'm just drawing opposite and then expanding on that. If everyone got this, I would like to move on to the next topic. Okay, let's move on to the next topic. The next topic is, I'm going to clear here. The next topic is reactions of Reactions of alkenes. Reactions of alkenes. Alkenes undergoes three different reactions: hydrogenation, hydration, and polymerization. So what is hydrogenation? Hydrogenation is nothing but addition of hydrogen. So we can add hydrogen. I'm going to explain the significance of this reaction. But addition of hydrogen, H2, on a double bond is called hydrogenation. Addition of water is on a double bond is called hydration. Everyone knows the difference between hydration and dehydration. When water leaves your body, you are dehydrated, right? When you're drinking a lot of water, you're being hydrated. So when you add water onto a double bond, it's hydration. When we remove water from a molecule, it becomes dehydration. So let me show you guys. You can visualize like this. So if this is a system, chemical reaction, if you add water to the system, it's hydration. If you remove water from the system, it's dehydration. This is hydration. And this is, when you remove water from a molecule, it becomes dehydration process. So that's the difference. Here we are adding water onto the double bond, so it's a hydration. So what is polymerization? Polymerization is self-addition reaction. I'm going to explain that later. They attach themselves to form polymers. So polymerization is self-addition reaction to form polymers like PVC. PVC pipes, you guys heard about PVC? Polyvinyl chloride PVC pipes, they're used for plumbing. They're used for plumbing. Okay, so what is hydrogenation? Addition of hydrogen onto a double bond. Can I say this? Alkenes undergoes we are adding things to the double bond. So can I make a statement like this? Alkenes undergoes addition reactions. Because we are adding stuff onto a double bond, because we are adding stuff to a double bond, so alkenes undergoes addition reactions. Now, addition of hydrogen onto a double bond is called hydrogenation. Addition of water on a double bond is called hydration. Self-addition of these molecules with each other is called polymerization to form polymers like PVC pipes. We are going to look at these reactions. So we are going to discuss all these three reactions under alkenes. So let's start with hydrogenation. I want to give you guys a commercial application of hydrogenation. For example, if you think about hydrogenation, you guys learned about hydrogenation of unsaturated fats. This is a commercial application of hydrogenation reaction. So what it is please write down. Vegetable oils. We can buy vegetables oils from HEB. Vegetable oils like corn oil or safflower, contains double bonds. These oil contains double bonds. And by using hydrogenation, by adding hydrogen, we can convert these oils into saturated fats such as margarine, which is more like a solid. So this is what they do commercially. They take these products which contains unsaturated fats, and they convert them into saturated fats, which are more like solid. Now, what also they do is by adjusting the amount of hydrogen added, you can actually control how much hydrogen you can add onto this double bond. Produces fats such as soft margarine, solid margarines in sticks, and shortenings. And we use shortenings for cooking. So for example, just to give you guys an example, if I take olive oil, if I add hydrogen gas to olive oil, olive oil is converted into stearic acid, which is a saturated fat. So olive oil contains double bonds, carbon-carbon double bonds. When you add hydrogen to it, it becomes what? Saturated fat, which is carbon-carbon single bond. So this process is called hydrogenation. Hydrogenation. So now I'm going to show you guys hydrogenation process. So let's actually work on the reaction. I'm going to clear this. Can I clear this, everyone? Please send me the message. Okay, so I'm going to clear this and I'm going to show you guys what is hydrogenation. Hydrogenation is having unsaturated fat on addition of hydrogen produces saturated fat. So can I also convert this equation like this? Unsaturated fats are alkenes. If I take alkene and if I add hydrogen, I can convert alkene into what? Anyone? Please send me the message. If I have an alkene, alkenes are called unsaturated fats. If I add hydrogen to alkene, it can be converted into what? Alkane. Yes. It can be converted into alkane. So alkenes are converted into alkanes by hydrogenation process. Now you can take any alkene, it doesn't matter what it is. So let's take a simple alkene. If I take a simple alkene, C double bond C, this is alkene. I'm going to stop the lecture after this reaction because we have to do the lab. Plus hydrogen, H2, can I write like this? H2 can be written like this, H dash H. Now, if I add hydrogen, what happens? This is converted into alkane. Now you guys can see that double bond is becoming single bond. And now I can add one hydrogen on this carbon. I can add one hydrogen on this carbon because now the double bond is becoming single bond. Now instead of having two hydrogens, now I'm going to have how many hydrogens on this? 3 hydrogens. Now instead of having one double bond, now we have a single bond. Now please look at here. This is how you can think of. Now please look at here. If I take this compound, can I place this hydrogen molecule exactly underneath this? Now please look at here. This carbon is picking up this hydrogen, and this carbon is picking up this hydrogen. Now, in order for this carbon to pick up this hydrogen, we have to break this bond. So let me remove this bond. If I remove this bond, then I have to remove one bond from the carbon because carbon can form only how many bonds? 4 bonds. So carbon cannot take this hydrogen unless I break this bond and this bond. If I do that, you guys can see carbon has space to take up the other hydrogen atom. So it will reduce, that's what the term that we use, we can reduce the double bond to a single bond. Now carbon can take up that other hydrogen and be fulfilled with 4 bonds. Any questions on hydrogenation? Any questions? If you don't have any questions, can I clear this? Okay. Now, let me show you guys. Let me show you guys the other alkene. What if I do this? So what is the product of this? Please look at here. This is the double bond. This is the double bond. This is the double bond. So what happens? The double bond, I had to add 1 hydrogen here. I had to add 1 hydrogen here. And I have to add 1 hydrogen here. So what happens? That compound becomes this compound. Now even look at the names. This is cyclopentene. Cyclopentene becomes cyclopentane. Even if you look at the names, you are just changing the "ene" to "ane." So if I take butene on hydrogenation becomes butane. If I take cyclohexene on hydrogenation becomes cyclohexane. Everyone see that? If I take 2-methyl-1-butene, if I take 2-methyl-1-butene, let me write down here. If I take 2-methyl-1-butene on hydrogenation, on adding hydrogen, becomes what? Becomes, anyone, please send me the message answers. It forms what? Please send me the chat message. Just by looking at the name, we can tell. If I take 2-methyl-1-butene, look at the here. If I take cyclopentene, it's forming cyclopentane. If I take butene, it forms butane. If I take 2-methyl-1-butene, it will form, yes, 2-methyl-1-butane. That's the product. 2-methyl-1-butane. That's the product. What about if I take 3-methyl cyclohexene? If I take 3-methyl cyclohexene on hydrogenation, please send me the product. If I take 3-methyl cyclohexene, please draw the product. Send me the product. 3-methyl cyclohexene will form, yes, most of you got it right. 3-methyl cyclohexene will form 3-methyl. So we don't even need to write the structure. We can just look at the name and tell what happens to that compound. 3-methyl cyclohexane. 3-methyl cyclohexane. So you can draw the structures, or you can just look at the names and draw the product. So the generalized equation is alkenes will become alkanes on hydrogenation. So please remember that. Alkenes becomes alkanes on hydrogenation. So let me stop here for the lecture.